All right, welcome back everyone. We have 3.5 vectors, maps, and C structs. And like always, don't forget to support the channel and subscribe. Now, what are you going to learn in this lesson? You're going to learn a lot of different things, all right? You're going to learn why we need vectors and how to use vectors with live code examples, why we need maps and how to use maps with live code examples, and then what structs are with a live code example, and then a quick code. Okay, which is your turn to, practice the things you learned in this lesson. Okay, now vectors and maps and structs are all really data structures. Okay, and so learning how to master data structures will help you better fine tune your programs. Okay, so we're going to start with vectors. Okay, why do we need vectors? And the first main point that we really have here, just let me bring up my pointer, is that arrays are fixed size. Okay, and if you look at this array, it's a very simple example. We made an array of size 3 and we gave it 3 spaces, which means what if this was about test scores, right? And you take a 4th test, what do? Right? Well, here, if we make an array of size 3 and we need more, we can't just add a 4th element. Arrays are fixed size. Okay. And then an example, if we wanted more elements, we would have to create a new array that is bigger and copy over all the previous values from the old array. Okay, so we would have to sit there and go, crap, I need a new one. Let's make a new one, right? And I would have to take all of the elements from the old array, put it into the new array. And this is going to take some time to write this, especially then you have to check, do I need more, right? Now, of course, you could sit there and go, well, what if I just created the array instead of size 3, I created it of size 300? Because you're not going to take 300 tests in a year. You're going to hope that you're not, right? Well, the problem with that is now you have a ton of memory being reserved, right? Because even though you haven't filled it with data, you have reserved that memory, which means it's being taken up, okay? And so we don't want to just overuse memory if we don't have to, okay? That's a bad practice. So let's get into vectors, all right? So on the left, we have an example, and you're probably noticing a couple things. For starters, how we make vectors looks kind of scary, right? We got some angle brackets here with data types, but if you ignore this for a second and you just look down here, it looks no different than an array, right? This is exactly how you would assign a value to an array. You would choose an index number and you'd give it a value. Choose an index number and give it a value. Choose an index number and give it a value, right? The VI vector was for ints, and so that's why I'm assigning ints. And then here, same thing. The VS vector was for strings, and I'm doing the same exact thing, okay? So the first thing I want you to think about vectors is they're just like arrays. And in fact, they have arrays under the hood, okay? They're using arrays under the hood. And I'm going to get to what makes them different in a second, okay? Now, in order to use a vector, you need to include the vector class in your file at the top. And yeah, vectors are created just like arrays, except for we have to express the type between the angle brackets after the word vector. So you say vector, no space here, angle bracket, you put the data type that you're going to store. And with an array, it's a little bit different, right? You put the data type first. So how we make them is different, but how we use them is very similar, okay? Now, okay, let's see, where are we at here? All right, now we gave it a size here of size 3 also. We could have done a different one. We could have left that empty. Either of those would have been fine, but I like to choose to give it a size off the bat. Okay, so that way, very early on, we have a good size. Now, what's different about a vector? That process of making a new array every time you needed a new array is what a vector will do for you behind the scenes. So it is an array, but let's say right here, I've made it of size 3 and I fill 3 spots. And then I go, I want to make a 4th one, right? The vector behind the scenes, when you assign the 4th value, is not going to give you an error. It's going to sit there and go, dang, we need more. Okay, let's double the size of the array, make a new array, and then copy all those values over. Okay, so behind the scenes, every time you need more space, the vector will give you more space, but it is still an array underneath, okay? All right, now another cool thing about vectors is they come with a ton of functions that make them very easy to use, okay? And there's more than this, but these I feel like are going to be the most helpful. So the first one is just whatever the vector name is. Then you have your dot operator. And then if you call size, you'll get the size of the vector. If you call dot at and pass it an index number, it gives you the element at that index. Now you may be going, well, why do I need that if I can just use this, right? I can use the brackets and pass the index. Why would I need to go vi dot at? And that's going to be for when you use vectors with pointers. Because if you use vectors with pointers, you're going to need to call the function, okay? Now vi.front returns the first element, vi.back returns the last, okay? Because remember, the size is always changing, right? So we want the last element sometimes. We may not always know where it is. vi.pushback, this is how you add a new element, okay? So and you put the data type here. So when I go vi.pushback and I send it a new number, it's going to add that to the end of the vector, okay? vi.popback is going to pop the last element off, and what that means is it'll delete whatever's at the end, okay? And then even cooler here, we can insert, right? We can sit here and go, I want to insert at the 5th index, I want to put a 10, which means if there's already 10 elements there and I want to put something in the 5th, it's going to shift the last 5 elements over to put my 10 in, okay? And then vi.clear, which can just clear the whole vector if you need to, okay? Now, vector is a class, okay? And because vector is a class, we should send it as argument the same way we would a class. We send its reference to a pointer and then use the arrow operator to access its members. So here's just an example, right? If I wanted to print out everything in a vector, just like for an array, I need a for loop, okay? But, and you could kind of achieve this with without pointers, but if you ever wanted to make a change to something in that function, you're going to need to send it as a pointer, assuming that it's not in another class, okay? But it's the same thing as what you would have done with the class. You would say, I'm going to take this parameter, this vector, I'm going to put a star, and every time I call a function with the pointer, I'm going to use the arrow operator. No different, okay? So this for loop goes from the 0 index to the end of the vector, and then I have to call the at function instead of using the brackets to get an index number, okay? And I can overload it. So look, print vector, this one takes a string vector, this one has an int vector, and both of them work. Now remember, when you're sending a reference, you have to use the reference operator, okay? That ampersand. So, you're linking the reference to the pointers right here, okay? All right, so that's vectors. Let's do a little live code to kind of get used to them. Okay, so in order to use a vector, the very first thing we have to do is include vector, okay? And now we're just going to create a super basic vector, okay? And we're going to store ints. So I'm going to go vector int, just like that. I want a vector, I want its data type to be an int, okay? And I got to give it a name. So I'm just going to call it, we'll just call it numbers, okay? Because that's what it's storing numbers, right? And then I have to give it an initial size. Let's just go with 3, okay? And then now we have a vector of size 3. I'm just going to give this a quick compile. All right, no errors. All right, we're good. So this is how you do it. Now, just, a vector is like an array. So I have 3 of those sizes, so I don't need to do pushback. Pushback is when I'm trying to add, when I don't have index numbers yet. Okay, so I could say here, I can go numbers of 0 is equal to 100, right? Numbers of index 1 is equal to 1,000, and numbers of 2, which is equal to 10,000, okay? And if I want to print out those values, I can just simply call them by index, all right? So that should print out 100. Let's give this a compile, and let's give it a run. Wow, okay. And 100 prints out, everything's good. Okay, so super simple so far. This is the vector, right? This assigns it values. Here's how we print out by a value. Now, if I want to add to that vector, okay, I can go numbers.pushback, and I'm just going to add, let's just add 5, very noticeably different, okay? And then let's print out what should be in the third index, okay? Which I know that we said that there's a 3 here, right? But that size means there's 3 index of 0, 1, and 2. So we never said that this should have, technically the 4th place or the 3rd index, right? But because we pushed this back, the vector needed to grow in size, and so it did. So compile, run, and boom, that 5 prints out, and that vector behind the scenes changed its size for us, okay? Now, we saw a ton of other functions, right? We can print out the size of the vector, so vector size, right? Ooh, here we go. Numbers dot size. All right, and then we can even delete stuff off. So let's delete something off. Let's go numbers dot pop back. Okay. And then let's print out the size again so we can see the size of that. And in fact, let's put a size right here so that we can see what the size was before we ever even added anything. Okay. So let's save this and compile it, and boom, vector size was 3, right? We added that value, and now all of a sudden vector size is 4. So everything's working the way it should. Now I'm going to create a function that's going to print out all those vectors. Okay, so I'm going to go, void print vectors. And in fact, before we do this, let me show you why we need this. If I want to print out all the values in a vector, I can't just call it by name. Same thing with an array, right? So if I go cout and I just pass it numbers, which is the name of the vector, and I go to compile, you can see there's just a ridiculous amount of error information right here, right? We can't do that. So when you're using arrays and vectors and eventually maps, it always is very helpful to have a method that prints the whole thing, okay? So I'm going to go void print vector. It's going to take an int vector, okay? We could just call it, vi, like we did in the video. Now I'm going to set this to be a pointer, okay? You technically don't have to for just the printing out of it, but I want people to get in the habit of learning how to send them as pointers, because again, if you send a vector to a different function to change it, then you have to do it as a pointer, okay? So we're going to loop through the size of it. So int I equals 0, I is less than vi, and now we have to use the arrow operator. I can't do this. I can't go size like that because it's a pointer. So I just use the arrow operator and call the at, which helps me just like the brackets do to get the index. And I pass it I, which is our index number, so that each time the for loop increments 1, right, it's going to change the index being printed. And I'm going to go I++, and then I'm going to go and print out, oh no, I did this completely wrong. I'm sorry. This needs to be size. We're looping the size, and then we'll print out the element. So element at, and we'll print out the ID, or excuse me, the for loop number. So element at this number is, and then we'll actually go vi arrow operator at I, like that. Okay, so that's a lot there, right? Let's put a space there too. And then let's call this. So just to, because I made that mistake, this should have been size. So I go from the 0 index to the size of the vector, right? And then I'm calling the at function because I can't use, there is a way to use the brackets with pointers, but it's just not as nice as calling the function. Okay, so that at function can be very helpful. All right. So at the very bottom here, I'm going to call print vector. I'm going to pass it my vector, but I remember I'm passing its place in memory. And that should print it out. So let's give this a compile. Let's give it a run. Boom. There it is. Okay. Now, why would you want to use this as opposed to using arrays? All right. And it all comes down to this. It's dynamically sized. Its size will change as we need it. And that can be very helpful because then you're not wasting memory or having to implement that yourself. Okay. All right. Let's get back to our code and let's look at maps. Okay. So here we have, moving on to maps and, why we need maps. Okay. And again, we have some pretty simple whys this time. For starters, here's a vector of type int called survey results that's set to 100,000, off the bat. Normally not what you would want to do, but let's kind of get down to the point here, right? Keeping track of things, or keeping track of where the results belong, especially if things get reorganized, is next to impossible with arrays and vectors, okay? What I mean by this is, a lot of times we may want to reorder surveys, okay? And then programmatically, what's in the 10th index anymore? What's in the 1000th index anymore? When you use vectors, the order sometimes may be least to greatest, greatest to least. We can order things like that way by moving things around, right? But, what if we want to search things up a different way? What if we don't want to search things up by number, right? For instance, with 100,000 results, if we want to find, a person named Kevin's results, which index is Kevin at, right? So maps allow us to organize our stuff, because it's, again, another data structure, or sometimes called a collection because it collects a bunch of stuff, right? That allows us to access our value with something other than an index number, okay? Because arrays and vectors, we just index number. Send me a 10, I'll give you what's in the 10th place, right? With maps, if you notice, we send it a key, or what we call a key value pair, okay? So we set string to be the key, and we set int to be the value, which we could have set it to something else. We could have said char was the key, or int was the key, or, well, I guess boolean to be a key would not be very good, right? But we can set this to be any type we want, and we can set the value to be any type we want. We want a string to point to a string, by all means. We want a string to point to a class, like a player. We can do that. Okay, so we can search, hey, give me the gamer tag as the key. I'll give you the player object. Okay, so now the order doesn't matter anymore. Who cares what the order is? Because we can jump immediately to where the data is with a key. Now, in order to use maps, you have to include the map, and then, kind of read off some of the stuff. Map is a data structure, acts as a dictionary with key value pairs instead of an index number. Yeah, we did that. We don't have to use string it. We can do any combination. Good. Okay. Now, it's just like an array, except for in the brackets, we pass it the key, and we set it equal, this is actually creating a new value here. So we're saying we want the for abacus key to point to 1,000. We want the dude key to point to 100. And when we grab it, we just pass it the key. Okay. Now maps also come with functions, right? And they're very, very similar to vectors, except for insert is much, much different. So we have, the name, and dot size returns the size of the map. Now insert is much different. When you insert, you can't just pass two arguments. You have to pass what's called a pair. Okay, so we pass it literally, kind of a map pair. So, and it needs to match what your map was. So our map was a string and then an int. So we say, hey, let's pair a string and an int and make that pair, Mike that points to 12. Okay, it's a little bit new here, but it's included with the map class, and you don't have to insert that way, right? Okay, and then we have name age.clear, which will clear the entire map if we want to. All right. Okay. Now we can also loop through maps, but here we're kind of bringing in some C++ 11 and higher tactics. If you're using REPL, they opt into the latest standard, but I feel like most of the time people are talking about C++, like 98, 99. And then, you can notice the auto keyword. This is C++ 11. Auto basically is a way of saying that whatever comes out of this collection here, we're going to auto the data type to whatever it is. So it's kind of like a JavaScript where we just go var, or Python where we don't even say anything. We just give it a variable name and it infers what it is based off the value. That's what auto does for C++. And we're setting it to be a constant, so it doesn't change. In fact, let me do a little bit overview of this for loop. This is much different. This is called a for each loop, and it makes looping through collections like maps and vectors much easier. We put the vector name here, and then, kind of how in a regular for loop, the I variable will be a new value each time. That's what this will be on the left. This pair here that we're calling it will give us access to the first pair in the map. And then when that for loop, that iteration ends, it'll give us the next pair, okay? If you're super confused about this, I plan to start getting into these a little bit more. However, you can kind of use this for now, all right? Now, because I said this brings back the first pair, you can go pair dot first to get the key and pair dot second to get the value, okay? All right, let's do a live code. Let's test some of these things out. All right, so we are going to work with maps. So the first thing we have to do is include the map data structure, or excuse me, the map kind of class, which is a header file. And then we're gonna get right into making them. So we use the map, and then we have to, in brackets, send a key and then a value, or at least what those data types are gonna be. So I'm actually gonna go string string. So my key will be a string to access a value that is string. And I'm gonna call this address book. So now we have a map with a string called address book, okay? Now I can add things to it two different ways. I could sit here and I could say address book, and in the parentheses I can go, the key would be for abacus, and then set it equal to Las Vegas, okay? Now notice here, vectors was a little bit different, right? Vectors, we already had index numbers, and if I wanted to add something new, I had to use the pushback. Here with maps, I could just right off the bat add a new value by just going, here's the key, and set it equal to it. Okay, so let's prove that that works. So let's go C out, and we'll call address book, send it the key, send it the key for abacus. Ooh, what happened there? Okay. And then let's make sure this works. And it does, right? Just the value prints, not the key. So we get a key to access a value. Now there was that weird pair thing I showed you, right? There's another way. We can call address book, and I can go dot insert and send it a pair, okay? And keep in mind, pair comes from the standard namespace. So the only reason why I don't have to do SCD, : pair is because I'm using the standard namespace, okay? And then I use the string, and then in parentheses, I put the key and then the value. And so I can go, Mike, and let's say, DC, all right? And that with a semicolon, and then I can print out, send it Mike to get DC. Compiles good, and it runs, and you can see Las Vegas and DC are printed. Now, why would you want to use one versus the other? If you're not using a pointer, this is the best. If you are using a pointer, remember, it's easier to call a function with a pointer than it is to use the, bracket operator. So, this would be better for a pointer, okay? Now, let's talk about that for loop. I don't feel like my explanation on those for loops was the best. So I'm going to go for, and let's do this. This is called the enhanced for loop, or it's called the for each loop. And this is perfect for looping through collections. To use this one, you say for, okay? And let's, kind of to do some pseudocode here. It's the, data on the left and the collection on the right, okay? So I'm going to say, and I'm going to use the auto keyword, okay? And I'm going to use auto constant, and I'm going to go use and grab the memory location for pair, all right? And then on the other side, I'm going to use the address book because that is my map, all right? So I have collection on the right, and then a single piece of data and what it will be called on the left. So the way this for loop works is it's going to loop through this whole collection here. And each time we pull, we're going to pull a key value pair. Then when we loop, we're going to pull a key value pair. Then we're going to loop, and we're going to pull a key value pair. Okay. The way we access those is through this variable pair on each loop. Okay. Now I understand this is a little new here. Auto will, look at the data and go, what type do I need to be? All right. Especially since if you think about this, if it's returning a key and a value, it is really returning a type of pair right here, okay? So it's best sometimes to just use auto when you're like, what's going to come out of this collection might be super weird, and I don't want an error to happen, okay? All right, so let's do this. Let's go cout, and let's call pair.first, and then let's go cout. Let's call pair.second. All right, the first one would be for the key, and the second one will be for the value. All right, so let's save this. And let's run it, and you can see, boom, look at this. This is that second one, Frabicus, Las Vegas, Mike DC. It printed out the key and then the value, all right? Now, you don't have to use it this way, okay? There are many, many different ways to loop through a map. I feel like this is one of the most simplistic ways, okay? But, sometimes it could be different, okay? All right, so this is maps. When do you use a map, okay? And you honestly use a map when an index number to find something is not good enough. Think about an address book or a dictionary. We often think of these like dictionaries. In the dictionary, you look up a word, but you look up the word to find its definition, right? So if I wanted to create a dictionary, this is perfect, right? I can set my keys to be the word, and I could set my values to be the definition for the word. Okay, so they point perfectly, okay? So that's maps, and we're going to get on to the last thing, which is structs. All right, so this is the last thing we're going over. Whoa. And this is what's called a struct, all right? Now, structs predate classes. So before we had classes, we could use structs, or we really refer to them as structures, to bundle variables under a single name. This was used in C before C++ existed. In the C programming language, you do not have classes. They do not exist, okay? What we have is structs, okay? Now, in C, you cannot put functions in structs. You can only put variables inside of a struct, okay? And you may be going, well, then how on earth did people program before classes? You could put function pointers in a struct that points to a specific function, right? Because that function pointer in a way is a variable, right? Because it's a pointer, it just points to a location in memory. That's just a standard variable. But the entire way you program in C is much different than a way you would program in C++. Okay. And if you think about it, all the functions like that you would put in a class, like get gamer tag or save gamer tag or what's the passcode. If you just pass it that function a struct, it can manipulate their variables, right? So it's just a different way of thinking. So why am I showing this to you? I want you to be able to be a little backwards compatible with looking at C, okay? Because you'll see a lot of code out there that is mixing up C and C++, or sometimes you're going to see that there's not something done in C++ because they just use it in C. For instance, networking code is all written in C. There's not really a lot of C++ standard library stuff for networking because it's all just done in C. So sometimes you have to be backwards compatible, okay? So the way to make a struct, all right, is you literally just say struct, you give it a name, and then inside you list its variables, semicolon at the end. And that's it. That's a struct. Now, you make a struct, like an instance of it, by going struct the name and giving it its own object name, kind of like you would with a class, but you have to put the word struct here, and then I access it through the name. p1.name is equal to Frabicus, p1.score is equal to 1,000, okay? And I can create many, many copies of this, okay, and print them out the same way. They're super, super similar to classes, okay? And I want you to see these. Now, in C++, what gets even weirder is that C++ kind of has its own version of struct, and it is literally identical to a class. In C++, you can use structs that have functions in them, and it literally is just a class. It's so similar. The only difference is if you don't put access specifiers, like if you don't write public, private, protected, it'll default it to a different one than a C++ class is. Like they're so similar. So, my advice is if you're going to use a struct, it's more to just kind of know what they are, okay? So let me do a little bit of live code, and then I'll give you your quick code. Okay, so here we are. We're going to create a struct. So we just go struct. I'm going to call it student this time. And I'm going to give it, S1. A student should have, a string name, and it should have an int or a double GPA. Okay. Now notice how I don't give these any values. I'm not giving them a single value at all. All right. And then to create one, I go struct student, and I'm going to, oh wait, I'm sorry, I did this wrong. You don't put the name up here. All right, this is where I'm just defining what the struct looks like. Down here, I put the name S1. And in fact, let's do another one. Let's go struct student S2. Okay, and I can go S1.name equals Frabicus. S2.name equals Mike. All right. And now when I go and print those out, I just call them again S1.name, and S2.name. All right, let's give this a compile. The fatal error that I always forget is a semicolon after the brace, just like for classes. You do the same for structs. And I run this, and you can see that those names print out. It is, if I was making a class for a student, think about how similar it would be, right? Class, student, I start giving it variables here, right? But then I would add functions. That would be the difference, okay? But it's almost identical, all right? So remember, I'm showing you structs so that you can look at C code also and know what it does, so you can be backwards compatible, because there are times where you need to be. Okay, so here's the last thing, all right? Building off of 3.4, all right? In 3.4, everything that is in black for this UML diagram you would have already done. I want you to add a couple things, okay? All the stuff in blue. So you need to add two class member variables, and they're gonna have a class grades, which is a map, which is gonna be a string and a double, okay? The string should be the name of the class. The double should be, the percent grade, all right? So English, 95, math, 82. I hope that makes you understand, all right? And then assignment grades, just a double vector. Now, of course, we would want something else that better references those assignment grades, but we're just trying to get some vector practice here, okay? So this would just take a bunch of assignment grades, okay? Now, you need to add a couple functions down here. You need to add set class grades and set assignment grades. And what these should do is prompt the user to enter in their class grades and assignment grades, okay? So they shouldn't actually take any arguments or parameters. They should start it off by going like, hey, what are, your class grades, okay? Now, if you think about it, at this point, you should already have an array for class schedule, right? So you can sit there and loop through this class schedule and go, hey, for English, what's your grade? And then you can pass it English for the string, for the key, and whatever the user gives you. So you can take the keys from class schedule, use them to prompt the user, and then store the answer they give you as the double part for the map, okay? Then set assignment grades, you should just, ask them, kind of very similar thing. I guess that was this part. The student should enter in their grades, assignment grades. So just, they should be able to enter, as long as they want. All right. So they start entering in, they go 10, 50, 30, but maybe if they give you a -1, you stop at, they stop being able to enter. Okay. And then the printing of them, you should be able to print the map and print the vector. So the print class grades and print class assignment should loop through the vector map and just print out what it is. Okay. So that's your addition to practice maps and vectors. You won't be practicing any structs. It's just a good to know. I hope you guys enjoyed it, and I will see you guys next time.